In this lesson, we'll learn how to configure preferences that affect computer performance so that your system will work at maximum efficiency when running Ableton Live. So again, I'm going to go into Preferences, and that's under the Live menu or Options menu on a PC. And I'm going to go to the Audio tab. So let's first talk a little bit about latency and setting the buffer size setting. So computers work more efficiently when there is a larger buffer. And essentially what's happening is that a chunk of data is being held for the CPU, and when the CPU is ready, it can grab it. And the larger that piece of data is, the more efficiently the computer is going to work. But there's a payback for that when using audio applications, and that is delay as the signal passes through the system. And that delay can be particularly annoying when you're actually recording, because you'll play the note and then you'll actually hear the note. As we look right now, my buffer size is set at 128 samples, and my input latency is about 3.7 milliseconds, and the output 4 for a total of about 7.7. That's actually quite low, and you'll probably be okay with a buffer size setting like that. Now, when you're mixing and editing, you can bump that up to a much larger size. And you should be also aware that when you change the values in this buffer size field, Ableton Live will let you type any figure in there. But many interfaces actually work with preset sizes like 64 or 128 or 256 samples, and then multiples of that. So in some cases, you can actually type a number in here that will cause a conflict with your interface. So you'll want to find out what those options are with your particular interface. But we can actually test this out and see how this particular interface that we're using with Live right now will work. And we can do that using this cool little utility that they've built into Preferences down here under Test. So what I can do is I can actually run a test tone so that I can listen to the audio as it's passing through the system, and then I can simulate a heavy CPU load by setting this CPU usage simulator parameter at a higher setting. So I'm going to click in there and I'm going to bump that all the way up to 80%, and then I'm going to turn on the test tone. Now right now I've set this pretty soft so that we can actually talk over the top of it. So there's the test tone. And if I look over here in the CPU usage field out in the Live window, we can see that it's seeing 80% CPU usage. Now what I'll do is I'll click in the buffer size setting field and I will put in a smaller setting. So we'll try 64 samples. I'll hit enter. I'll listen. It doesn't sound too bad. Let's go down a little bit lower. And you can start to hear a little fuzziness happen there, definitely at 32 samples. This particular interface will let me go all the way down to 20 samples. You can immediately hear some crackling there in the background. So if I was going to record into this system, I would probably start at either 64 or 128, knowing that a total of about 7.7 milliseconds is not going to cause a problem with latency in recording. But if I was to get up to something like, let's say, 512 samples, you can see that I would then be looking at over 24 milliseconds of latency, and that is going to be noticeable. In my experience, I'll just let you know that that actually is kind of the breaking point. So usually I would do this at least at 256 or lower, and we can hear that the audio is unaffected by that buffer setting. And I'll turn off the test tone here, and let's drop down and take a look at the preferences under the CPU tab. And the first one here is the multi-core multiprocessor support. And this enables spreading the CPU load over multiple processors if available on your computer. Now, when do you need to worry about that, or how would you know? Well, you can always take a look out here on the CPU load meter in Live. And if this is up near 100%, that shows that the computer is working at its maximum ability, and you may end up with some pops or clicks or distortion or dropouts. So if this occurs, you're going to want to increase the buffer size setting on the audio tab that we were just talking about. And there are some other things like freezing tracks that we'll talk about in a later video. While we're out here, there is a disk overload indicator. That's the one here with the D on it. And note that hard drive speeds affect the performance of programs like Live. So most computers today have 7200 RPM drives, which are sufficient for running audio applications. But those of you who are using laptops, you probably have a 5400 RPM drive, and you may run into problems with high track counts and other issues where you're taxing the machine. If that happens, you may want to reduce the track count, come back to the Audio tab, and raise your buffer size setting. But in any case, there's no reason why you wouldn't want to enable multi-core and multiprocessor support. Another parameter we'll take a look at here is the plug-in buffer size. Now currently this says as audio buffer. And what that means is that when we're routing audio in live to an audio effect, like a compressor or an EQ or something of that nature, it's going to receive the same buffer size as the rest of the system. In some cases, if you're having problems with the CPU overload or other issues, you may want to come in here and try and set this to a higher setting. So this can be different than the actual CPU buffer setting. But normally, we'll leave that as audio buffer. Okay, so in this lesson, we learned how to configure the preferences in live that affect system performance. This will enable you to set up your computer in live so that they will operate effectively.